When the space race first began, scientists didn't even know if it was possible for humans to eat in a zero-gravity environment. Once they figured out it was possible, it didn't mean that it wasn't without problems. There was a host of issues with eating in a zero-G environment that had to be overcome. Some foods were able to be made edible in space, and some never were. Learn more about what astronauts eat in space and how they do it on this episode of Everything Everywhere Daily. I wanted to let all of you know that the 1-year anniversary of this podcast is coming up on July 1st. In celebration, I'd like to do a special episode and answer all of your questions. If you have questions about past episodes, future episodes, how I produced the show, or questions about me personally, I'd be happy to answer them. Feel free to send me any questions you might have via direct message on Twitter or Instagram. I check those regularly. Likewise, you can also ask on the Discord server, or you can send me a direct email at gary@everything-everywhere.com. Send in whatever questions you have, and I'll try to answer as many as possible. If I have too many, I'll split them up into more than one show and spread them out. You can find my email address and all the links I mentioned in my social media accounts in the show notes. As I noted in the introduction, it wasn't even known at first if it was possible to eat in a zero-gravity environment. Chewing, swallowing, and digestion all follow a downward path, which is helped, at least in part, by gravity. They probably knew it would work, given that you can swallow food upside down, but you never really know until you try it. The plan they came up with for the very first space travelers was pureed food, which was put in the equivalent of toothpaste tubes. This would then be consumed by sucking it through a straw. The initial meals were based on military rations modified to be used in space. Oddly enough, the Soviets and the Americans, who were not sharing any information with each other, initially came to the same conclusion for the problem of eating in space. When Yuri Gagarin first went into space, he had 2 tubes of pureed meat and 1 tube of chocolate sauce. The first 2 American space flights were suborbital and only lasted 15 minutes, so the astronauts didn't bother eating anything. However, during John Glenn's flight, which consisted of 3 orbits around the Earth, he had tubes of applesauce, pureed beef and vegetables, and some sugar tablets and water. What the Americans and the Soviets both discovered independently was that humans can in fact eat and digest in space. When the Soviets sent their second cosmonaut into space, they discovered something new. German Titov became the first person to vomit in space. Now called space adaptation sickness, it's a form of motion sickness which affects almost 75% of everyone who goes into orbit. While you can eat in space, that doesn't necessarily mean that you can keep everything down in space. As the Mercury program flights became longer, they tried eating more types of food. In particular, in addition to the pureed foods, they tried dehydrated powders. This was the period that gave us Tang, which was actually developed back in 1957. The reviews by the Mercury astronauts of the food they were given weren't good. For starters, freeze-dried foods proved difficult to rehydrate in a zero-G environment, and most importantly, the food didn't taste very good. In the first Gemini mission, Gemini 3, John Young snuck a corned beef sandwich on the flight because it was the favorite sandwich of the mission commander, Gus Grissom. This was totally in violation of the mission protocols, and it was done in secret. This was actually a bigger deal than it might seem, and illustrates one of the reasons why astronauts were given the equivalent of baby food to eat. Bread has crumbs. Crumbs in space can float all over the cabin and get inside sensitive electronics, and potentially cause a short circuit. They ended up not eating the sandwich and got chewed out when they got back to Earth. One of the biggest developments during the Gemini program was the creation of freeze-dried foods. Freeze-drying is actually a great way to preserve food, even if the process is a bit involved. As the name suggests, freeze-drying involves bringing the food to below freezing, then exposing it to a vacuum. The water in the food sublimates, which means it goes directly from a solid to a gas. The Apollo mission saw further development in space food. They introduced the spoon bowl system where astronauts could eat out of a Ziploc bag with a spoon. Also called wet packs, the moisture was contained in the bag and the food didn't have to be rehydrated. They also created a way for food to be rehydrated with both hot and cold water. Previously, everything was done with only cold water. Despite the improvements, the Apollo program food still wasn't great. The longest mission was only 12 days, which is short enough to just suffer through with standard astronaut fare. All of the Apollo astronauts lost weight, and their dietitians realized that they weren't consuming enough calories. The Skylab program involved much longer stays in space, up to 3 months. This would be far longer than any previous American space missions, and the issues of nutrition and taste became even more important. For extremely long missions, the psychological well-being would be improved by a greater variety of foods. One of the things they did on Skylab was introduce a refrigerator and a freezer. For the first time, that allowed for perishable food in space. Previously, everything had to be shelf-stable. Skylab also had a dedicated kitchen and dining area. The number of types of food available to Skylab astronauts were dramatically larger than in previous programs. 72 different types of food were available, including such items as shrimp cocktails, chili, ham, steak, asparagus, and mashed potatoes. The Soviets had their own space station, Salyut 1, and they were actually growing their own food. They grew tomatoes and cucumbers, growing and eating the first space produce. It wasn't a big garden, but it was something. On the Apollo-Soyuz mission, which I had discussed in a previous episode, the two crews shared their food. The Soviets had canned beef tongue, borscht, and caviar. With the advent of the Space Shuttle program and eventually the International Space Station, astronauts from many more countries began flying in space. That meant more foods from other cultures. Japanese astronauts brought sushi and ramen. An Italian astronaut made the first freshly brewed coffee in space, and the Koreans brought kimchi. One Swedish astronaut even brought moose jerky. In most of these cases, a lot of development went into creating a version of the food that was suitable for space. For example, the South Koreans spent over $1 million to create their space kimchi. In the 1980s, at the height of the Cola Wars, both Coke and Pepsi created cans that could deliver a carbonated beverage in space. In 1985, on STS-51, they tried the cans created by both companies, but the results were very mixed, and they never tried it again. One of the cans designed by Coke is currently in the National Air and Space Museum in Washington, D.C. Today, astronauts can request foods, and what is sent up to the ISS will often be what they want. Many astronauts prefer spicy food when they're in space because without gravity, their heads get congested and they can't taste or smell quite as well. One of the big problems for the future of space food will be feeding a crew on a mission to Mars. Even on a year-long International Space Station mission, the crew is resupplied every few months. A mission to Mars will not be able to be resupplied. If a supply ship was sent to Mars before a crew, food sent on the supply ship might have to sit there for years before a new crew arrived. Also, once astronauts get there, they may be forced to grow food on the Martian soil, which has never been done before. In fact, Martian soil isn't even really soil given that there is not any microbial life in it, and possibly no nutrients whatsoever for plants. Entirely new methods of crop production and food storage will have to be developed to make a Mars mission possible. There have been a lot of advancements in the area of spaceflight in the last few years, and we are getting closer to the day when civilians and tourists might be able to fly in space. When that day happens, you too might be able to have some freeze-dried ice cream or canned beef tongue in zero gravity. The associate producer of Everything Everywhere Daily is Thor Thomsen. Today's 5-star review comes from listener Emperor Severin on Apple Podcasts in the United States. They write, "Review. Succinct, informative, elucidating, precise, focused. Appreciated." Attention, Emperor Severin. Acknowledgement, thanks, gratitude, appreciativeness. Remember, if you leave a review, you too may have your review read on the show, even if your review doesn't use complete sentences.